Hello everyone and welcome back. This is another productivity video in our Autodesk Inventor Professional tutorial series. If you remember, we previously did a productivity video about the keyboard shortcuts, the right-click menu, and the view cube, some of the tools that help us work faster and more efficiently in Autodesk Inventor Professional. But today's video is different and, in my opinion, much more exciting and much more important. So, why is this more important? I'm especially excited about this topic because every time I teach this in person, when we get to this part of the training, I can see it in people's faces clearly, especially beginners who are learning a CAD software for the first time. This part of the training really motivates people. It encourages people. It's such a great confidence boost, and it shows people that learning a CAD software isn't as difficult as they thought. And now, if you're already experienced with a CAD software, if you've built assemblies before, this is nothing new to you. In fact, it might even feel a bit basic or maybe boring. But please keep in mind, and I'm sure you'll agree with this, for beginners, this is one of the most important concepts to understand. It's very simple. And oddly enough, this topic isn't included in most of the online tutorials. It's often missing from even paid courses that charge people a lot of money to just have access to the content to learn a CAD software. And I think it's a shame, but in this video, we're going to cover it properly. We're going to talk about it, and we're going to use it frequently in the following videos because I think it should be included in every CAD training, whether it's SolidWorks, Fusion 360, or Autodesk Inventor, whichever one you use. This is something that should be part of any essential CAD training. So to explain what I'm talking about, we're going to ask two key questions. The first question is, can you design everything in Autodesk Inventor Professional? The answer is yes, you can design pretty much anything. And the second question is, should you design everything from scratch? Should you design everything? The answer is a big no. And that's what we're going to talk about today. So, what do the professionals actually do? The experienced engineers, designers, and the technicians, people with years of experience, experts in CAD software, CAD design, they don't design every part themselves. Even at companies that build some of the most innovative products out there, the design teams in those companies, they don't model every single component. Why is that? Because a lot of those parts they use already exist. They're readily available. Those professional CAD files are out there waiting for you to use it. And I'm not talking about some random user shared models, something that some guy somewhere created and shared it online. I'm not talking about that. I'm talking about high quality, precisely designed professional CAD files provided by suppliers themselves. And these companies share all these files because they want to earn your business. They want to attract customers. So if you use their CAD files, which is free, you don't have to purchase anything. But if you get to a point when you realize that, okay, this project can turn into a profitable business, let's build a prototype, you will most likely purchase those parts from that supplier because you use their files. You just want to make sure that there are no mistakes. So they offer their CAD files for free. You can download them directly from their websites and they're ready to use in your assemblies. So let's just think about an example. Maybe we're designing a drone, and in a second we're going to look at it we're going to Google it as well, and we're going to look at some of the images. So let's say you're designing a drone, and visualize it. Some of its components, like the body, propeller mounts, or the camera housing, or parts like that, they will be custom parts. You will have to design those yourself. But other components like screws, bolts, washers, bearings, or motors, they are standard parts. You're not going to waste time designing a screw from scratch. You'll just download it. So that's why this matters, because remember, your goal is not to design a screw. So if maybe you came up with a idea about a different type of screw that doesn't exist anywhere, if that's your design goal, sure, then it makes sense to design a screw because that's your design goal. In that case, I mean, in this tutorial, we're going to have videos about how to design a screw. All of that will be included in this tutorial series. But if your goal is not to design a screw, if your design goal is to design a drone, for example, the screw is just one piece that helps you complete the overall design. So using a ready-made CAD file from suppliers that helps you focus on what really matters, which is your final product. So let's just get out of this presentation and look at some of the images. So let's go to Google. Let's go to Google and let me delete this. Yeah. So let's just search for drone. And let's look at the images. And as you can see, there are so many different types of drones used for different applications, made by different companies. And you can see that, some of them are using this housing, for example. This is unique to this assembly made by this company, and it's not available in another design. So that design uses another custom made part, so you have to design those. But to be able to mount them together, maybe you're using some screws, and technically that same screw can be used in this assembly or this assembly, and those screws are most likely purchased parts. They're not custom made parts, so you just purchase them from a supplier. That means you can get the files from that supplier because again, your end goal is to design the drone, I'm sorry. So now let's look at one of those suppliers, and most commonly used one is McMaster-Carr. So when in the previous videos, I believe in the exercise videos as well, we used M5 screws. So let's say we're looking for M5 screws. And now, let's say it's the socket head screw. I'm just selecting the first option. Let's say we're looking for a 16 millimeter threaded screw. And let's click on that, click on product detail, and you can see how big it is actually. You kind of get an idea about what it looks like, and you have a 2D drawing. Let's just zoom in and see the dimensions. And remember when we talked about the hole feature in this tutorial, and if you go back to that video, I'm sure you will remember, we said in the hole feature properties menu, if you don't know how to enter values here, what enters you should enter here, then in the following videos, we're going to talk about it. Of course, if you have the experience about, if you know what, if you're already familiar with this, you will know what values to enter. But if you have no idea about, how, what the diameter should be, what the length should be, you can always come here to the supplier's website and find a screw that looks like it's going to work for your design and get the dimensions from their drawings. So to give an example for that, let's say we start a 2D sketch on an XY plane. Let's use the 2-point center rectangle. Let's say this is a 100 by 100 square. And then let's just extrude that. Let's say it's a 50 millimeter extrusion. Now, let's say we're putting a hole in the middle, and I don't want to use the last used one. Let's just no preset, and I can change this to tapped hole and counter bore and metric profile M5. And so now I want to see what values I need to enter here. So let's just go back and select maybe a smaller screw. So let's say it's a 10 millimeter screw, and click on product detail. Let's say we want to add a hole for this screw. Let's look at it. And this one is 8.5 millimeter in diameter for the head, and the depth is 5 millimeter, and the length is 10 millimeter. So let's just do that. So it's 8.5, so let's add, we can add 8.5 here, or we can enter 9 here, which is the head diameter, just give extra space. And for this one, let's say I believe it was 5 millimeter in depth. Let's say we want this to be 6 millimeter, so it's not completely flush on the surface. It can kind of go down a little bit. And let's say instead of a through all, we want this to be distance. So and then if we put a hole here, and we want this hole to be uh, say this let's say 25 10 millimeter hole, so it's going to be 10 plus 6, 16 here, and 16 here. Yeah, because 6 millimeters of it is the depth, so I want this to be 16 millimeter here, so that's I have 10 millimeter here, which is going to give me what I need. So let's just call this 20, actually a bit bigger than that. So let's click OK. Now if you look at it, you have the counter bore here, that's where the head of the screw will sit, and you have the threaded section, which is going to be about 10 millimeter of a threaded section, and you have some extra space here at the bottom. So now when we purchase the screw, it's going to fit here. So now I know exactly what values I need to enter. I can kind of leave extra space for the screw, or I can just enter the same exact values, but looking at this number. But that's not what we're here to talk about. So let's just say that I am creating an assembly and I want to use this screw, but I don't want to design this from scratch. So I can come here and select 3D step from the drop-down menu here, and I can select download. And now this step file will be downloaded to my downloads folder. So now I can just go to Autodesk Inventor and click open. And then in my downloads folder, I can't see it right now because it is looking for Inventor files. I'm just going to select all files from the files of type. Now I can see that step file that I just downloaded. So I can click open. And now it's going to bring me this conversion table. And we're going to talk about this in more detail in the future videos, but basically what it wants you to specify here is what do you want to import? What kind of conversion do you want from this part? But let's just use the default settings here, and let's just click OK. And it's going to import that step file and create this IPT file for you. Now you didn't have to design this part, but you have access to the CAD file in seconds. And you can do the same thing with many other parts on this website. We just did this for the screw, but say you can do the same thing for hinges. I can just enter and find a hinge. Let's say it's a 1-inch hinge here, and I can download the 3D step file for that and go to Inventor, click Open, and now I can select that hinge. Click again, make sure that this all files are selected so you can see it, and click on it and click OK, and select OK for the conversion. Now you have access to this CAD file as well. And just this, you can find many other components like that on that website. And and this also brings us to the next important thing about this concept, because sometimes you have to design this screw. And I've had to design a custom screw before, for example. Sometimes, depending on the application, like in a special machine, I had no choice. So yes, there are exceptions where a custom part is necessary, but those situations, for a screw, those situations are rare. Here's why, designing a custom screw is usually not preferred. So let's look at the process you have to go through. You have to model the screw in CAD, so you have to design this. That takes time. And then you have to create a 2D drawing. We're going to cover that in this tutorial. But you have to create a 2D drawing because you have to send that to a supplier. Supplier needs to understand what dimensions you want from this part. What kind of dimensions need to be used in the program. And then you have to research and contact a local machine shop, maybe something like that, right, to fabricate the part. And you need to request a quote from them and wait for them to get back to you. And you need to approve and schedule the job, which can take even more time. And they have to program and machine the part, because this is not a standard item. They don't do this every day. They don't make the same part every day. They have to do it for you. It's a custom made part. And you pay for everything: material, labor, setup, and lead time. So that increases your cost and the time. Maybe you don't meet your deadlines if you do this. So the downside is pretty obvious: time and cost. A lot of this takes time, a lot of time. And it's expensive because you're not just buying a part, you're creating a one-off product. So let's compare that to buying a standard screw. Imagine you're using a standard screw. You download the CAD file, the one that you can see, for example, the one you can see on the screen right now, and from the supplier's website. And this is the perfect representation of what you're going to get. And so you order it online. I don't know the lead time on this. Let's check it. So let's just go back to that screw right here. So let's just go product detail, delivers tomorrow. It delivers tomorrow. So you order it online, it gets delivered the next day, and you just pick it up. Maybe if it's really standard, you can just pick it up from Lowe's or Home Depot in a few hours. It's cheap, fast, and there's almost zero lead time. And because these companies make millions of these, it's very cost effective. Now, this one is $13.91 for 100 of them. So if you get this made like as a one-off product at a machine shop, it's going to cost you a lot more than that. So it's cheap, fast, and there's almost zero lead time. The supplier manufactures millions of them every year, so that's why they're cost effective. So another problem with this long-term problem with custom screws, if we take it a step further, imagine you use a custom screw in a machine you deliver to a client. A year later, their technician is troubleshooting the machine, the screw breaks, or it gets lost. It happens all the time. Or the customer loses it. And they now have a big problem. It's not a standard screw. They just find that out, and they're not going to be happy with you about that. And they can't just go buy a replacement, right? That's the big issue. They need the 2D drawing, and they need to go through the whole custom fabrication process again. Everything we just talked about. They'll spend more money, wait longer, and trust me, they won't be happy about it. So that's why this matters. That's why both engineers, designers, and customers prefer standard components whenever possible. If its standard part exists, use it. It reduces your lead time, lowers the cost, and makes life easier for everyone involved, now and in the future. Again, we can go back to the main homepage of McMaster-Carr, and this is just one website, by the way. There are many others. We're going to use many other supplier websites in the following videos in this tutorial, but let's just take a look at a few other things. So you have threaded bolts, you have nuts, washers, and you have spacers here in the fastening category. Pipe, pipes, and we designed a pipe in an exercise video before. So if I want to, I don't know, maybe download something like this for a project I'm working on maybe, and I click on this, again, 3D step file is available. So it is downloaded in my downloads folder. Now let's just select that and convert it. Now I can, it's just importing it. It's on the other screen right now. Yeah, now I have this part here that I was able to import in seconds, right? So this part here, which is a straight connector. And again, if you want, maybe you want a part that looks like, let's just go down a little bit, something like this. Yeah, let's look at it. So let's download this. And again, go to Inventor, click Open, select that file that you just downloaded, and convert it. And notice that every time I import this in the browser tree, it shows me the manufacturer part number and even the description of the part. So if I create my assembly and use this part, and when I create a 2D drawing of it, and if I add a bill of material, for example, automatically the manufacturing part number and the vendor information and the description will be populated there. So that's going to save me a lot of time as well. But and also I know a lot of people, for example, come to these websites and they download some of these parts and 3D print it. And in this tutorial, we had a video about how to create an STL file from an IPT part file. So you can also explore that as well if you want to, create STL file and 3D print it. And again, if you look at the other categories, you have bearings, bushings, pulleys, for example, you have shafts. You're not going to custom make these. You're going to purchase them if you need them in your design, in your prototype. Again, you have actuators, you have bearings, and come down here, pumps, valves, in the previous video, for example, I'm sure you will remember we used, when we were talking about the sweep feature, I believe, we designed tubing, and we said this is commonly used in pneumatics, when you design pneumatic lines for equipment. So let's say we go tube fitting. So let's say we're looking for a tube fitting like this and something like this maybe. And this is the tube fitting. Let's say this is the adapter we're going to use to connect that pneumatic line. So we can just download this and then come to Inventor again, open it, and then convert it, and that should be available to me again in seconds. I can use this in my design. And you can, of course, select which type of tubing, which kind of thread, which kind of length, what kind of length you want, and you can always determine that. But many other parts are available here, even like machining parts, fabricating parts, power tools, Allen wrenches, conveyors, material handling stuff. I believe even they have furniture. Yeah, furniture and storage. You have tables and chairs. So again, extruded aluminum, for example, if you want to build something and build a frame around it, you can also purchase, get the CAD files for that. Plumbing and janitorial, yeah, heating, cooling, and just you can find a lot of things on this website that can help you with your design and basically save you a lot of time and help you meet your deadlines. So that's why they're very important. But of course, like I said, this is not the only website. We also know that one of the commonly used websites is Misumi. You can also find fasteners here, automation components. I'm not going to go into a lot of details because in the following videos, when we create assemblies, we're going to create some custom parts. Also, we're going to come to these websites and we're going to download these CAD files from these websites, and we're going to use them in our designs. We're going to orient them and position them in the correct way. And so we're going to take advantage of some of the parts in Misumi websites as well. Another one that I can think of right now is SMC. I use it sometimes when I needed to download some air cylinders. I know that they provide a lot of pneumatic components. Yeah, got their CAD files from SMC website, used it in my design. So when I created the drawings for that assembly, the people I shared this with, they immediately knew, okay, he used the SMC part here. This is the manufacturing part number, and I can just immediately find it because the all the information I need is available for me in the design, and that's why they know that, okay, this person already made it easier for me to understand design and use the design and even build the design. So yeah, and we're going to keep doing this in the future videos. This we looked at some of these websites, and I'm sure some of you will be able to maybe recommend other websites. Please, add them to the comment section here. What other websites that you use to take advantage of these professional drawings? But in the following videos, as we go into the assembly mode, we're going to use these websites commonly. We're going to design our own parts or take advantage of these professional designs. And like I said, this is something that is very important. It's an essential knowledge in CAD software trainings to take advantage of existing professional designs. So I'm excited to use this and talk about it more in the future videos. See you in the next videos. Take care. Bye bye.